Okay, we're on day 2 of verifying trig identities. Our goal for today is I can establish trigonometric identities. So what you can see here is the beginning of today's notes all involve, they're basically just like, hey, if you see this, try this. That's what they are, okay? And it's just all a warm up right here of things that we worked with yesterday. Then we move on to what you would actually see on your test, which is called establishing an identity. So if you look at the left-hand side of the problem, it's exactly like what we have been doing, okay? But if you notice on the right-hand side now, I give you what you're supposed to get, okay? So we only have 4 of those that we're doing today. And then in the next notes, we're practicing again. It's just a lot of practice with it, okay? So without further ado, let's get started on today's stuff. So first off, I always start by putting my 3 trig identities down, okay? So you can pause the video, start by writing down the 3 trig identities. Now, if you're like, what are the trig identities? I don't know what you're talking about. The first one is sine squared plus cosine squared equals 1. And hopefully you're like, oh, yeah, I know what you're talking about. And you write down the other 2. Okay. All right, next one, tan for 1 second. So tangent squared plus 1 equals secant squared. And then the last one, coat Christmas. I don't know how this is Christmas, but it's okay. Okay, so there's your 3 identities. Now, I will see some people write down all of the reciprocal identities, all of the quotient identities. Reciprocal identities would be like cosecant is 1 over sine, like those. I'll see people write down quotient identities, which is like tangent is sine over cosine. You can write down everything. You can write down your cofunctions. Sine and cosine are cofunctions. I don't write all those down. These are the 3 I always write down, though, no matter what. Okay, let's get started. So let's say you get to a problem. I'm going to get rid of the word that tells you what to do right here. So let's say you get to a problem and you're like, I don't know what to do. I don't, secant and cosine, there's nothing squared here. Can I replace secant with 1 over cosine? Yes. Is that going to be helpful? I don't know. It could be, okay? But at some point, you're going to say to yourself, well, nothing's helpful right now. I'm going to have to distribute. So if you see something you're not sure to replace it with, this is not something squared and something squared, and it's not simplifying for you, then distribute. So we're going to distribute. Cosine of alpha times secant of alpha is cosine of alpha, secant of alpha. Cosine of alpha times cosine of alpha, this is a minus, and then that's cosine squared of alpha. So first thing I notice is I see a cosine squared here, and that's like, ooh, that might be part of my identities, but this over here is not being helpful for me right now. So I say, okay, cosine can stay, but what can I change secant to? I can change secant to 1 over cosine, so that's what I'm going to do. So I have cosine of alpha times, and I can replace secant with 1 over cosine of alpha. And then I still have minus cosine squared of theta. Remember, I'm not touching this because it's separated by subtraction. It's over there like it doesn't exist right now. Can, however, put this over 1. And I can say, oh, cosine alpha over cosine alpha is 1. So I have 1 minus cosine squared of alpha. So now I say, ooh, 1 is 1 squared, cosine squared. I got a 1 squared and a cosine squared. I've got an identity. So I look over here. I hope I have an identity. How can I manipulate one of these, which is going to be the first one, to be 1 minus cosine squared? I would have to subtract cosine squared from both sides. I'd be left with sine squared on the other side. So this is equivalent to sine squared of alpha. Don't forget your angle name. And we practice, notice I have alpha, gamma, beta, theta, gamma again. I have a bunch of different angle names because your variable is not always x. You got to get used to using any variable, just like if I said solve for q, you could get q by itself, right? Okay. So let's say you get to a problem that looks like this, and if I asked in class right now, what's jumping out to you as like, well, it's going to be this cube, right? It's like the cube. I don't even know what to do with the cube. If you see a cube, we don't work with anything as high as cubes. We work with squares. So I have to get it down to a square. In order to do that, I would have to factor it, Okay, so if you see a cube or a fourth power or anything like that, factor it. So whenever I'm factoring, the first thing I always look for is a GCF. So I'm going to look at my two terms. Here's one term, two terms. Do they have anything in common? They have a cosine in common. So I'm going to factor out cosine of gamma. When I do that, I have cosine squared of gamma plus sine squared of gamma. So then I say, okay, anything out look good here? And I say, ooh, what looks good? This looks good. Cosine squared plus sine squared. That looks like my first identity. Cosine squared plus sine squared. That's equivalent to 1. So now I can say I have cosine of gamma times 1, which is cosine of gamma. Okay? Once again, steps are important. If I see someone go from this to this, they copied it off of someone else 100%. It doesn't just pop into your head. Okay, here I see a sine squared, so once again I'm getting rid of the directions and telling you what to do. We're gonna arrive at that. So here I'm like, ooh, a sine squared and a cosine squared. Like, that's my first identity, right? So I go back and I say, okay, I just gotta manipulate this so it's sine squared minus cosine squared. Well, this is sine squared plus cosine squared. The first thing someone will say to me, oh, it's -1. No, I can never make this a minus cosine squared. I can bring it to the other side and get it to be a minus cosine squared, but then I would have to bring this over there and be a minus sine squared. So you're never going to be able to get sine squared minus cosine squared. It's just never going to happen, okay? Just like you're never going to be able to get tangent squared minus 1 or 1 minus cotangent squared. It's not going to happen. So if you ever see this exact thing, but this sign is wrong, this exact thing or this sign is wrong, so on and so forth, that means you're going to want to try to factor it. Okay, so when factoring it, the first thing I look for is a GCF, and they have nothing in common, but I do notice that they're both squares, and it's a difference. So this is a difference of squares. We know how to factor a difference of squares. Let me give you another example of a difference of squares. I factor this to x plus 3 times x minus 3, right? Okay, that's how I'm going to factor this. It's a difference of squares. So I know that I can have my two sets of parentheses. I have sine of theta times sine of theta is going to give me my sine squared. This is going to be positive and this is going to be negative because outer and inner have to cancel. Cosine of theta, cosine of theta. Okay, now, do I get to go anywhere from here? No, I'm stuck. But in a normal problem, you wouldn't be. I'm just saying if you ever see that, this is what you're going to do. Okay? So if you're saying to yourself right now, like, how is that better than the beginning? I think this is better looking, personally. But it's just if you were in a problem, you were trying to get it to look like something else, that would be my next thought process to do that. Okay, next one. So first off, I want you to notice the difference between D and F here. Because they both look like fractions, right? It's something divided by something, something divided by something. But what I want you to notice is the big difference between them. This is just one term. This is two terms because it's separated by subtraction, okay? So when you have something with just one term in the denominator, and also I don't see anything else here. Okay, so like here, this right here, this is two terms. It's a 1, then plus sine of theta. So it's separated by addition, so it's two terms. Now I also want to point out this right here. This is also two terms. 1, 2. So if this was just the only thing in the denominator, that's one term because it's not separated by addition or subtraction. It's multiplication. I want you to realize that, and I'll show you more examples in the future. Okay, so when you have just one term in the denominator and it's division, looks like a fraction, then divide. Okay, what you can do is divide if nothing is looking good to you. So what I would do, remember you have to divide both terms by this. So I would have a cosine of beta over cosine of beta. Now if you're like, isn't that one? Steps are more important. And I have the plus sign. And I can divide this. So sine of beta divided by cosine of beta. All right, cosine of beta over cosine of beta is 1 plus, and then what can I change sine over cosine to? Tangent. and then of beta. Right? All right, next, I see two fractions. I say to myself, hey, is there anything that I can change? Oh, 1 plus sine. It's not sine squared, so there's nothing I can do here. But it's two fractions. Most likely, I'm going to want to make it 1. Okay, what do you mean if I'm saying most likely? I'll already tell you what I'm trying to get it to look like. Most likely, I'm going to have you try to get it to look like 1 fraction. How do I make two fractions 1 fraction? I combine them. I add them. So in order to add two fractions, what do I need? I need a common denominator. What's my common denominator? It is cosine times 1 plus sine. So if you want to write that right above it, you can, just to like make notes here. It's going to be cosine of theta times 1 plus sine of theta. Don't forget your thetas. It's the most common thing people do, but it doesn't make any sense if you lose them. Okay, so I'm going to multiply this fraction by 1 plus sine of theta over 1 plus sine of theta. And I multiply this fraction by cosine of theta over cosine of theta. Okay, so now I'm going to write down I'm going to get 1 fraction from this. So I just like to make my 1 fraction right away. I like to write my common denominator, cosine of theta times 1 plus sine of theta. And then I'm going to write down everything that I have in my numerator. That's just my personal preference. So I'm going to multiply these two. Cosine times cosine is cosine squared of theta. Right? Then I have this plus sign right here, so I put the plus sign. And now I have to multiply these two. Notice it's 2 terms and 2 terms, so I do need to multiply it out, distribute, FOIL, whatever you want to call it. 1 times 1 is 1. 1 times sine is sine, but that's outer and inner. Oops, and inner is also sine, so I have 2 of them. So I'm going to put plus 2 sine of theta. And then last times last, sine times sine is plus sine squared of theta. Now, right now, you might be looking at this and saying, like, I feel stuck because this is hard right now. I'm not going to say it's easy stuff you don't know what to do, but I want to remind you that there's going to be an equal sign and the answer already that you're trying to get on the other side. So you're going to have tips and you're going to be like, oh, yeah, I need to do this because it needs to look like this. So I'm going to say, does anything jump out to you in your numerator? Okay, does anything jump out to you in your numerator? What jumps out to me is this cosine squared and this sine squared. Okay, sine squared plus cosine squared is 1. So what I can do is I can take those two, this right here and this, and I can simplify that to just a 1. Okay, so now I have 1, I'll even put it over here. I have 1 plus 1, which is 2, plus 2 sine of theta. So I have 2 plus 2 sine of theta over cosine of theta times 1 plus sine of theta. Okay. All right, the next thing I notice about my numerator is that I have 2 terms, and they have something in common. They have a 2 in common, so I can factor out the 2. If I factor out the 2, I have 1 plus sine of theta over cosine of theta times 1 plus sine of theta. So now I look and I say, ooh, there's a 1 plus sine of theta in the numerator and in the denominator. Those cancel. Now I have 2 over cosine of theta. Now, once again, you might be saying like, ooh, am I done? You would notice on the other side that you wouldn't be done because I would tell you what I'm trying to get, and this can be simplified. If you think about it, this is the same thing as 2 times 1 over cosine of theta. And this step can be skipped right here that I just wrote. And I know that this is secant of theta. So this is the same as 2 secant of theta. So if you skip this step because you're like, oh yeah, it's 2, that's 1 over cosine secant, 2 secant of theta, that's fine. But you can also write it out if you don't see it right away. Okay. Last but not least, this looks like a fraction, right? But what I'm noticing here is that it's 2 terms in the denominator. So when it's 2 terms in the denominator, you can't divide by the denominator. So instead, what you're going to do, if you see this, or what you can do, and also notice that I see a sine squared here. There's so many ways to do this one. I could change it to, what could I change it to? A sine squared. I can get this on the other, I can change it to a 1 minus cosine squared, and then factor. I could do it that way. Okay? I might actually show that way too also. But another thing that you can do is that you can rewrite it so it's not a fraction. How do you rewrite it so it's not a fraction? You multiply by the conjugate of the denominator. So the conjugate would be keep this the same and this the same, but you change the sign in between them. Okay. All right, so now what I'm going to do is I'm going to write my new denominator. Why am I starting with the denominator? Because I multiply by the conjugate of the denominator, because obviously something good's going to come from that. That's the whole reason I did it. All right, first times first is 1. Outer is positive cosine of gamma. Inner is negative cosine of gamma. So those cancel, so I'm not going to even write them down. Last times last is negative cosine of gamma squared. Numerator, I'm going to leave it as sine squared of gamma times 1 plus cosine of gamma. Why? Because distributing it makes it uglier, right? It becomes sine squared of gamma plus sine squared cosine. It would not be prettier. It would not be more helpful. So I'm just going to leave it. And now I'm going to say, okay, what can I do now? So now I say, 1 minus cosine squared of gamma. What can I change that to? So I look and I say 1 minus cosine squared. We just talked about that. If I get this cosine squared over here, that's equivalent to sine squared. So I can change this to sine squared. So I have sine squared of gamma times 1 plus cosine of gamma over sine squared of gamma. The sine squareds cancel out. And I'm just left with 1 plus cosine of gamma. Okay, so that's another thing you can do, is that if there's two terms in the denominator and neither one is a square, or both of them aren't squares, then you can multiply by the conjugate of the denominator, and good things will happen because you will end up getting two terms that are squared. Okay? All right, so let's move on to establishing the identity. So it's exactly what we're doing, except the answer is already on the paper, which is great. Okay. So it says a bunch of stuff right here. It's called an identity when one side looks like the other side. It's identical, okay? Here are basic guidelines for establishing an identity. So first off, you are going to start with the more complicated side. Usually that's going to be the side with the most terms, fractions. It's more complicated. Also, another thing that I want to point out, addition is more complicated than multiplication. So if you're looking at this and you're like, I don't know what side's more complicated. Addition is more complicated than multiplication. So this side is more complicated. Okay? Okay. Thing number 2. You can only touch one side. You have to pick a side that you're going to manipulate, and that's the only side you're touching. You are not touching the other side at all. As a reminder, rewriting in terms of sines and cosines can be helpful. So I leave sines and cosines alone. And then if I need to change, a cosecant to 1 over sine, I will. Always keep your goal in mind, meaning the answer's there. So if you're like, I don't know what to do next, look at the answers, see if that helps you. Last but not least, there are often multiple ways to do these. So if you do it a completely different way and still get to the end, your way is fine. Okay, let's get started. I'm going to start off by, you guessed it, writing my 3 trig identities again. Sine squared of theta plus cosine of squared of theta equals 1. Tan for 1 second. Tangent squared of theta plus 1 equals secant squared of theta. 1 plus cotangent squared of theta equals cosecant squared of theta. There's my 3 trig. That way I don't have to scroll all the way to the top, and it's good practice. Okay, so first step number 1, I'm trying to get one side to look like the other side. So I'm going to start by picking the most complicated side, and you're going to circle it or box it. I'm going to circle it. This is the side I'm manipulating. Okay, it's going to say on your test, circle the side that you're manipulating. Okay, so I know that I'm going to end up with cosecant of theta. So I'm just going to even move it over so that I don't even see it right now, but I will keep my goal in mind. Okay, so I need to decide what I'm going to do. So usually I ask for help in the class. What can I do? People say, oh, you can change tangent to sine over cosine. You can change cotangent to cosine over sine. And yes, this is all true. I will end up doing that. But the first thing I notice is that I'm going to have to distribute because right now nothing good's happening. So I'm going to distribute first. And if you changed things first, it's fine. You'll get there also. So that's cosine times tangent plus cosine times cotangent of theta. And then the equal sign. Don't forget the equal sign. And you can put cosecant every single time. I just wait till the end. Okay, now what can I do? I can change tangent and I can change cotangent to something. So that's what I'm going to do next. So I'm going to do cosine of theta times tangent. I can change to sine over cosine. And then cosine of theta. And cotangent, I'm going to change to cosine over sine. Okay, I'm also going to put this over 1 and this over 1 because, you know, I like to do that. All right, so this is separated by addition, so I just have to look at this right here and say, is there anything I can do? Well, the cosines cancel, so I'm left with sine plus. I look over here and nothing cancels, so I'm left with cosine squared of theta over sine of theta. Okay, so now is where I look at it and I look at the class and I'm like, now what? And I get crickets, okay? So here's where looking at what you're trying to get should help you, or at least I'm going to see if it's going to help me. So I look and I'm trying to get cosecant of theta. So what I say to myself is, hey, this is one thing. This is two things. How do I make this two things into one thing? I have to add them. I make two fractions into one fraction that are being added by adding them. So what I'm going to do is I'm going to add them. In order to add them, I need a common denominator. So first off, I'm going to put this over 1 to make it a fraction. And see that my common denominator is sine of theta. So I'm going to multiply this by sine of theta over sine of theta. Now I'm going to write my denominator, which is sine of theta, and I'm going to write one big numerator. So I'm going to multiply these two. Sine times sine is sine squared plus cosine squared. All right, so now there's still some people who get a little stuck and they're like, and then there's some people who are like, I got it, and they start moving, right? So if you're stuck, once again, look what you're trying to get. You're trying to get cosecant. Cosecant is the same thing as 1 over sine. I already have the sine in the denominator. I just need this to be 1. This is 1. It's my first identity. It's sine squared plus cosine squared, right? It's 1. So now I have 1 over sine of theta. 1 over sine of theta is the same thing as cosecant of theta. And now I just got cosecant of theta on this side. I have cosecant of theta on that side. Check it off because you just established your identity. There's some things that I want you to notice here is that I never, ever, ever wrote on this side of the equation because cosecant of theta has to go there every single time. So if you find yourself moving to the right of the equal sign, you're going to get points taken off, okay? If you're on the left side, you stay on the left side. If you're on the right side, you stay on the right side. If you need to write cosecant of theta on that side every single time so you stay off that side, do it. All right, let's try another one here. So we already discussed this, but this is the more complicated side. Why? Because addition's more complicated than multiplication. So I'm going to start by putting an equal sign right here. Now I just moved it over just so I can have more room. Okay, and I'm not going to look at that other side over there. All right, so what can I do here? And I say, oh, well, I can change tangent to sine over cosine. Plus, and don't forget your thetas. And then I look at cotangent and I say I can change that to cosine over sine. Okay. All right, now some people get stuck. Some people are like, hey, we just added fractions. I'm assuming we should add these fractions. Now, I don't like assuming, but if you look at this, this is 2 terms separated by addition. Okay? If you look at this, this is 1 term here. There's no addition or subtraction in it. So yes, you do have to add them because you need it to be 1 term. So in order to add them, I need a common denominator. My common denominator is sine cosine. So I need to multiply this by cosine over cosine. And when I say cosine over cosine, I mean cosine of theta over cosine of theta. And you multiply this by sine of theta over sine of theta. All right, now let's see what we have here. I'm going to make my one big fraction because this is going to give me one fraction. I'm going to write my common denominator, which is sine cosine or cosine sine. It's the same thing. And now I'm going to write my numerator. Sine times sine is sine squared of theta plus cosine times cosine is cosine squared of theta. All right, now what can I do? If you're stuck, look what you're trying to get. You're trying to get secant times cosecant. Secant's 1 over sine. Cosecant's 1 over cosine. Ooh, I have a sine and cosine in my denominator. That means that this needs to be a 1, and it is. So I can change that to 1 over sine of theta, cosine of theta. And now if I look, I need it to be secant, cosecant. So I want to say, I want to split this up so it's two different fractions but still being multiplied, right? I want this one to be secant, which is the same thing as 1 over cosine. And then this to be 1 over sine. Now, some people will be like, wait, can you do that? If I asked you to multiply this, 1 times 1 is 1. Sine times cosine is sine cosine, right? So if you're questioning whether you can do a step, see if you can go back to the original. If you can't, then you can't. If you can, then you can. All right, and then I know this is secant of theta times cosecant of theta. And that's what I was trying to get. Secant of theta times cosecant of theta. Check. So once again, what I want you to notice, well, you can't see it right here, but if I, it won't let me. But I stayed on the right-hand side. If you're like, no, you didn't, you wrote over here. I still stayed on the right-hand side. Just my big handwriting got on that side. But I never like put is equal to and then put something on the left-hand side. So notice you're staying on one side of the equation. All right, let's look at number 3 here. Which side is more complicated? It should be very clear that this side right here is way more complicated, right? Okay. So first thing I'm going to do is I'm going to look at it and I'm going to say, what can I do, right? So I'm going to say, ooh, is this an identity up here? Cosine squared minus sine squared. So I'm going to look to see if I can manipulate my first identity to be cosine squared minus sine squared. So I say, okay, can I ever make this a minus, or can I ever switch these two and make it a minus? And I say like, okay, well, it needs to be minus sine squared, so I'd have to move this. Let me get all these done. Over here, that'd be a minus sine squared, but then I'd have to move that over there, be a minus cosine squared. Just remember, you can never get that to be a minus right there between those two. If you recall what I told you to do, when it is a minus, it's to factor it because it's a difference of squares. So we're going to factor our numerator, cosine of x plus sine of x times cosine of x minus sine of x. Now, I just factored my numerator. Most likely, you're going to have to factor your denominator. Now, if I look here, the denominator is factorable. It's not a difference of squares, but it does have a GCF. Because if you look, these two terms do have something in common. They have sine in common. So I'm going to factor out the sine of x. And I have cosine of x minus sine of x. And then the equal sign. Okay, so now I'm going to look at this and see what I can do next. If you look, I do have a common factor from numerator to denominator. Remember, factors are separated by multiplication. There's multiplication here and multiplication here. So these two cancel. Now I'm going to write down what I have. I have cosine of x plus sine of x divided by sine of x. Okay, so now what you have is something that looks like a fraction. If you have a really good memory, you might be saying to yourself, you said when there's one term, we should divide. That is true. But let's say that I didn't know what to do next. Look at what you're trying to get. You're trying to get cotangent plus 1. What's cotangent the same thing as? Cosine over sine. I need the 1 still. That's sine over sine. So if you look at that, that might help you. So I have cosine of x over sine of x plus sine of x over sine of x. That's cotangent of x plus 1, which is equal to cotangent of x plus 1. Voila. Okay. Okay, one last one for today. What's the more complicated side? Make sure you circle it. That'd be this side. Okay, that sine of theta is clearly not as complicated. Okay, so there are so many ways to do this, so I'm actually going to show you more than one way to do it. I believe there's actually 3 ways that I can think of right now at the top of my head to do it. So I don't want to overwhelm too many people. So if you get it on the first and you're like, no, I like that way, then do it that way. Okay, so some people say the first thing that they see is that this is 1 term, 2 terms right here, and because it's separated by subtraction, and I need it to be 1 term, so I need to subtract them. In order to do that, I need a common denominator. So I'm going to put this over 1 and see that my common denominator is 1 plus sine of theta. So I'm going to multiply this by 1 plus sine of theta over 1 plus sine of theta. Then I have my denominator, 1 plus sine of theta. And then my numerator, I got to distribute this 1 to here, and it's still 1 plus sine of theta. And then I have minus, whoa, careful, minus cosine squared of theta. Okay, so now I have to say, what can I do next? And this is where people get stuck. So I look to say, I'm trying to get sine of theta. I am not there yet. But what I do know is that this whole entire thing has to end up canceling out. And what people will try to do is they'll try to say, I'll cancel it out with this. That's not going to get you to sine theta. Also, they don't cancel out because there is a minus sign right here. That is not a factor. Okay, if it was multiplication, it'd be a factor. So I have to see what can I do, because my denominator, there's nothing I can do with. What can I do with my numerator? Is there anything I can replace? I have a 1 and a minus cosine squared. So I'm going to look at my identities and say 1 minus cosine squared is the same thing as sine squared. So now I have sine squared of theta plus sine of theta over 1 plus sine of theta. Okay, so now what can I do? Can I divide? No, because it's 2 terms. What can I do? So I look at my numerator and I say, well, I can simplify fractions if I cancel out common factors. My numerator is factorable, but I didn't factor it yet. So let's factor my numerator. There's a GCF. Oops. There's a GCF of sine. So I'm going to pull out the sine, and I have sine of theta plus 1 over 1 plus sine of theta. And I say, wait a minute, those are the same. Boom, boom. So now I have sine of theta is equal to sine of theta. Done. So that's one way, okay? Now I'm going to show you another way because different people see different things, okay? All right, so here's another way, then I'll show you a third way. Why not? Let's make these notes extra long, okay? So another way that people could have started this is still start with this side. And you could have said, I see a cosine squared in my numerator. What can I replace cosine squared with? Well, cosine squared, I can get rid of this on the other side. That's the same thing as 1 minus sine squared. So I have equals 1 minus, and then I can replace that with a 1 minus sine squared of theta over 1 plus sine of theta. Now I can say this is factorable. Okay, it's a difference of squares. 1 minus, this is a 1 plus sine of theta. That's a difference of squares. So that's 1 plus sine of theta, 1 minus sine of theta. 1 plus sine of theta and 1 plus sine of theta cancel. I have 1 minus sine of theta. Distribute my negative. That's 1 minus 1 plus sine of theta. 1 minus 1 cancels, and I'm left with sine of theta. So that's the second way of doing it. And why not? Let's show the third way. Okay, so the third way is if someone came up and was like, I'm going to multiply, I'm going to do this side, I'm going to multiply by the conjugate. Okay, so if someone did that, I'd have, I'm going to go like this, I'd have the equal sign, and then I'd have 1 minus cosine squared of theta. Oops, I forgot to multiply by the conjugate. So the conjugate would be 1 minus sine of theta. So I'd have cosine of theta times 1 minus sine of theta. And then if I multiply 1 plus sine of theta, and I would do this up there, it's just that there's no room, or it just doesn't make sense if I do it up there. If I multiply those two, outer and inner cancels, and I'm left with 1 minus sine squared of theta. Then I can say, is there anything that's replaceable? And this 1 minus sine squared of theta is replaceable. It's if you look back up here, 1 minus sine squared, let me get rid of all these arrows here. If I got the sine squared on this side, it'd be the same thing as cosine squared. So I can replace that highlighted part with cosine squared. So this is cosine squared. And then I have cosine of theta here times 1 minus sine of theta here. Now, you do have a common factor from numerator to denominator, and that's cosine. Because we want to realize that this right here is the same thing as cosine of theta times cosine of theta. So one of these cosines cancels with one of these cosines. Okay? So now, you have 1 minus sine of theta over cosine of theta. Now I have two things, one of which is a fraction, one of which is not. So I need to make the other one a fraction and then get a common denominator, which is cosine of theta. So I'm going to multiply this by cosine of theta, multiply this by cosine of theta. So my new denominator is cosine of theta. My new numerator, 1 times cosine of theta is cosine of theta. And then I have to distribute this negative. So this is minus 1 plus sine of theta. I think I'm going in circles here. I might have made a mistake on this one somewhere. Let me try to find it. 1 minus cosine squared. Cosine. Maybe I shouldn't have shown my third way. Well, I'll do the third one in class. But this way works out too. It has to. I made a mistake somewhere because there's no way that it wouldn't simplify to sine of theta. So I got to figure out what I did wrong. Oh, I forgot the 1. No, I didn't. Is it? Well, I'll make a separate video in just a moment and figure that one out instead of wasting my time on this video. Okay, so forget the last way for now. This does work out though. I just can't see my mistake because it's just, I went from here to here and I just can't find my mistake just quickly enough for myself. I found my mistake. I'm going to come back and go like this. I found my mistake. I copied down the original wrong. So this original right here, this was cosine squared, and I just wrote cosine right here. So this was cosine squared. And then if you recall, this changed, cosine squared, this changed to a cosine squared of theta, and this was cosine squared of theta. That's why. Okay. All right, so then cosine squared and cosine squared cancel, and now it's just like the one that I did second. So 1 minus sine of theta. Distribute your negative. So that's 1 plus, or sorry, that's 1 minus 1 plus sine of theta. Ones cancel, and that's sine of theta equals sine of theta. So notice that like when I wasn't getting there, I knew I made a mistake somewhere, okay? But you don't have to do it 3 ways. I'm just showing you that this sentence right here, there's often multiple ways to do it. You can't. Most people end up doing it this way or this way, okay? Most people don't end up doing it this way, but it's not a bad way to do it if you don't make mistakes. All right, that's it.